Hi, good evening, everyone.
Good evening, sir.
Am I audible?
Yes, sir.
Good evening.
Yes, sir. Good evening.
Evening, sir.
Okay. So, myself, Anand Kumar,
So we'll
one
wait
of the
for we'll wait for 5 more minutes and we'll start the session, like 2 or 3 more minutes. Let people join. Like only 17 are there, no?
yeah.
Sure,
Okay,
ma'am.
Nalin.
Yeah. So hello everyone. Welcome to this programming concepts using Java course. And like for this course, there will be 2 live sessions per week. So the first session will be the concept summary session and also doubt clearing session. So if you have any doubts, you can ask in this session as well. And the other session will be coding, live coding session, where the coding will be done. So for the first week there is no coding, so the first session will be concept summary and the other session will be like doubt clearing session. And the I am one of the instructors of this course. I'm Nalini, and the other instructors of this course are Anand Kumar and Subendu, and also Bhaskar Banerjee. So yeah, so you can ask your doubts in both sessions, like in the concept summary as well as live coding session. Basically, mainly live coding session focuses on coding. So there will be some problem statement given, and you have to solve the question in that particular time frame. And in the concept summary session, basically concepts will be covered of that particular week, and you may also ask all the queries you have in this session as well. So I think now, answer, you can start.
Yeah. Thanks, Nalini. So, my voice is audible, right?
Yes, sir.
Yeah. Okay. Okay. Good evening, everyone. So, now I'm going to start a concept summary of week one. Okay. So, my screen visible, right?
Yes, sir.
Yes, sir.
Yes.
Okay. Okay. Yeah. See, first in this week, okay, we need to know about what is programming language. Okay, so Java is a object oriented programming language, right? Java is a object oriented programming language. Okay, so as of now, so leave about object oriented. First I want to know what is programming language. Okay, so any idea what is programming language? Anybody?
Like
So, like,
to communicate humans and between humans and machines.
Yeah. So now in this session, right? In this session, we are communicating with each other. Am I correct? So we are communicating with each other. Okay. So how we are communicating with each other? by using English. Am I correct?
Yeah.
So here English is a language medium we are using to communicate with each other. Okay, so here programming language. Okay, programming language is a communication medium between human and computer. Okay, human and computer. So here by using programming language. Okay, so programming language is one of the computer language. Okay, one of the computer language. So by using this programming language, so we are able to write computer programs. Okay, so basically communicate computational instructions to the system. So we are going to write some computational instructions to the system by using this programming language. Okay, so before programming language we have what low level language. Okay, so low level language. Okay, so this low level language is directly mapped to the architecture. Okay, so if you write okay any program in low level language, okay, in low level language, okay, that is tedious and error prone. Okay, so you if you write directly the program in low level language, okay, so that is tedious and error prone. But here in high level programming language, okay, so in high level programming language, so we are not writing program directly in low level language. So here we are using programming language to write computer programs. So this computer program these programs contains what computational instructions. Okay, so here programming language directly not understood by the computer. Okay, programming language not understood by the computer directly. Okay, here here this programming language again need to convert into the low level machine level language. Okay, low level machine level language. Who is responsible to convert this high level programming language into low level machine level language. Okay, so here low level machine level low level language means here computer can understand zeros and ones. Am I correct? Computer directly understand zeros and ones. Okay, yeah,
Yes,
now
sir.
yeah, here who will be converted this high level programming language into low level mission language. Yeah, that is my question. Who will convert?
Excuse me, sir.
Yeah,
Compiler.
Compiler
Sir,
yes,
I have a doubt
compilers.
here.
Yeah,
and interpreters.
yeah, somebody
Yes,
raised their hand, right? Yeah, doubt.
sir, I have a doubt here. High level language means the programming language, either C++, Java, Python, anything. Low level language
Yes,
is the binary language.
yes, binary language and assembly level language is also there. There we can use mnemonics to write the program.
Okay, what are
Both
mnemonics?
mnemonics means some symbols like move, xor, add, like that. We have some mnemonics.
Okay,
Those mnemonics too we can use to write the program.
okay, sir,
Okay,
it's clear.
so binary language and assembly level language both are comes under low level languages. So in programming language we use general English instructions to write the program. Okay,
Okay, sir, it's clear. Thank you.
yeah. So here compiler and interpreter. So we can use compiler or interpreter to convert high level programming language into low level machine language. Okay, now what is the difference between compiler and interpreter? What is the difference between compiler and interpreter? Anybody?
So interpreter
Uh,
does the work like one step at a time, and whereas
Yeah.
Okay.
compiler does it in one shot. The entire
Yes.
program
Okay.
is done in one shot.
Okay. So
Compiler run the code in a like the whole file at a time, and
yes,
interpreter reads line by line and
yes,
executes.
yes, yes, yes. Okay. So see here, I'm taking notepad. Yeah. So here you have a program. So like this. So I'm not writing program. Okay. So here 4 lines of code you have. For suppose 5 lines of code you have. Okay. Now, what compiler will do and what interpreter will do? So here, compiler is going to load all program as a whole. Okay, all program as a whole, and it is going to check. Okay, is there any syntactical errors in your program? If your program, okay, if your program follows what all programming language rules and it is syntactically fine, then it is going to convert your program into what your program into low level machine language. Okay, now what interpreter will do? So it is going to, okay, it is going to convert, okay, line by line instruction into low level language and executes it. So that is the difference. So here interpreter is going to convert what one by one instruction into machine level language and executes it. But compiler will take as a total file as a whole, okay, as a whole, and it is going to check is there any syntactical errors in your program or not, and if everything is fine, then it is going to convert into low level language. Is this clear for everyone?
Got it, sir.
Yeah.
So can you please give me an example where interpreter is used? Because suppose in Visual Studio Code we use compiler.
In Python we are using interpreter only, right?
So
In Python, yeah. So Python using interpreter only to execute the program.
but it executes all in one shot, no? The compiler.
No, line by line.
Okay. Okay.
Yeah. Okay. Next, styles of programming. Yeah. So here, two styles of programming we have. First one is imperative programming and declarative programming. Okay. So in imperative program, okay. So here we need to write what step by step instructions. Okay. So here we will focus on how to compute. Okay, we will focus on what how to compute. So here we should write, okay, we should write what program or solution, okay, step by step in detail. Okay, we should focus on how to compute. Okay, we should focus on how to compute. But whereas coming to declarative programming, okay, so we no need to focus on how to compute. Okay, so here we should focus on what the computation should produce. Okay, so to explain this, I have one example program. Yeah, see here. Yeah, imperative versus declarative program. See here, this right side and left side we have two programs. One is imperative and another one is declarative. Okay, so these two programs are, okay, used to find out sum of squares of even numbers up to n. Okay, yeah, now see in imperative programming. So in imperative programming, okay, so here we are writing, okay, in detail. Okay, in detail, first we are going to check, okay, first we are going to check whether the number is even or not. So if, okay, number is even, then we are going to, okay, we are going to perform square and we are adding it to the what my sum. So here my sum is a what intermediate or local variable. Okay, so it is used to find what a sum of squares of even numbers up to n. Okay, yeah. Now see at right hand side. So declarative programming. See in declarative programming, okay, in declarative programming, we no need to focus on how to compute. Okay, so in declarative programming, we are dividing our task into, okay, our task into functions. See here at left hand side. So for x in range of n plus 1, okay, n plus 1. So here we are checking, right? So whether your number is even or not in the given range, right? Yeah. Now if it is even, then we are going to, okay, find out the square and we are adding it to the my sum what variable, right? So here checking, okay, checking whether number is what even or not, okay, we are dividing it into one function, and I want to find out the square of a number. Okay, so that is divided into, okay, another function. Okay, another function. Yeah, now see what I'm doing is here first I am filtering. Okay, I am filtering even numbers in the given range. Okay, even numbers in the given range. Okay, so how by using this even function. Okay, so in this what range I am going to filter all even numbers. Okay, after that I am using map function. What map function will do here, it is going to apply, okay, given function to, okay, given function to every element. Okay, so whatever the even, okay, even number you have in this range, okay, for every element it is going to find out the square. At last we are going to, okay, find out the sum. Okay, so here we are going to write, okay, at left hand side in imperative programming we should focus on how to compute. Okay, so in declarative programming, okay, we don't need to focus on, okay, how to compute. Okay, just we are going to divide into what simpler manageable tasks, and we are going to, okay, we are going to get the solution in declarative programming. Is this clear? So and here see in imperative programming we are using some intermediate variables, see sum and x. So these are intermediate variables, but here we are not using any intermediate variables in the declarative programming. Is this clear for everyone?
Yes, sir.
Yes, sir.
Okay,
So
next
that is
very
clear,
important.
but is one better than the other?
Hello,
Hello.
hello. Yeah.
Yeah, but is one better than the other?
Yeah, declarative is better, right? So we are going to divide, okay, so our program into what smaller and manageable parts, right?
Yes, sir, but it might take more memory, or it might not be the most efficient method.
Why it is not efficient method? Here also for intermediate variables we need to allocate the memory, right?
Yes.
Yeah, so here also we need to allocate what intermediate sorry, memory for intermediate variable. See here for x in range of n plus 1, here we are going to repeat the loop up to n number of times. Am I correct? So here also for every iteration, okay, for every iteration we are going to allocate memory for x. Okay. Yeah, somebody posted something. Yeah, Rohit.
Uh, this method, the second one,
1 second. Yeah.
this declarative type, what we mostly observe is recursion codes, and it just uses the functions. And
Yes,
while
yes.
studying Python, we have been made aware of the fact that it consumes more memory, as well as we can only do some finite operations while writing declarative codes, especially recursions, and it consumes more memory. And it is suggested by the instructors to use imperative methods. I mean, they just wanted us to write mathematical code which execute faster. So, is there any trade-off between both of the methods?
Uh, Trade-off means
Means
there
in
is
some
no trade-off.
situation it should be preferred, and in some situations declarative is more preferable, like that.
Yeah, see, if your program is looking big, okay, if you are programming looking big and you are depending on what we call more than 10 operations. So here we are depending on two operations, right? Whether your number is even or odd, you should check. After that, you are going to find out square of a given number, right? So here your task is divided into what two subtasks, right? So if your program is okay looking big, Then you can go for declarative. That is the main use of the declarative programming. Okay, so you can divide your task into smaller and manageable tasks, and you can achieve task like this. And if your programming is looking very less code, if it is uh, if it is looking very small, then we can go for imperative programming. So that is the main idea.
Yeah, can I tell something? So you
Yeah.
can check for the what memory and also the computation time. So if you consider the imperative programming, you can see the number of iterations we are going through. So we are going through n iterations, right? The for loop is running from x like n plus 1 times, so the n iterations are required. While coming to the declarative style, what we are doing, we are just writing the some functions. So you can check for some computation time and also the memory our program is consuming. So you can consider like which one is taking the more time, which code is taking the more time with the imperative, or which one is taking the more memory. So based on that, you can implement your code. You can go for either imperative or declarative. So we can't mention like which one is better specifically, but we can consider these both cases, like the memory the program is taking, and also the computation the number of iterations the program is doing. That we can consider, and we can decide by ourselves like to go for which programming, whether imperative style or declarative style. So there is nothing like better among imperative versus declarative programming. It's our choice. Based on our requirement, we have to opt for either imperative or declarative. Is this
Hello.
clear? Yeah, yes.
Yes.
But the imperative is
Mm.
there is assignment of variable. For example, my sum equal to zero,
Yeah, that is
and it's
memory.
going to take more memory, right?
Yeah, yes, that takes more memory.
So
So
that is
base
also one of the reason it's imperative.
yeah, it's not so if you have less memory, then based on our requirement only, we can choose either imperative or declarative. If memory is not a problem for you, then you can choose the your imperative style. So in that way, in based on our requirement and based on our availability, we can go for either imperative or declarative style.
Ma'am,
How?
declarative also takes less time or
So in the case of declarative, so there is like what, are we iterating through any loop? No, right? There is no
no,
for
no.
loop or nothing. It's just the functions we are applying, right?
Yeah.
It takes less time compared to the imperative style. In the imperative style, we have to check for like how many iterations it is taking. So it is going like n times, no? So it,
Yeah.
it is, yeah, the iteration number of iterations, it is n iterations. So but in the case of this here, nothing, it's just function
Uh,
calls everywhere. Yeah.
Excuse me. In the case of declarative,
Mm.
it will also use the same loops because when we will use the map and the filter functions,
Mm.
I suspect that it will also loop through all of the items,
Yeah, it will also loop through all the items, but it's not
but
explicit.
its functionality is not
Yeah,
explicit, right?
yeah, it's not explicit. So it is just function call only. Its range of n plus 1 will generate the n plus 1 numbers, like 0 to n numbers, and then it will just apply those functions. So it is not like running every time, it will happen only once. Okay. But here this everything, if x mod 2 equal to 0, my sum, that whatever the statements which are inside the for loop, that will happen in every iteration. But if you consider this in the case of declarative programming style, this will all this whole function will be executed only once, right? So the range method will generate 0 to n numbers, and then even function you are even of even comma this range you are calling, no? So that function will be called, filter function will be applied, and this whole thing will happen only once. So in just single iteration it will happen. Okay, in the case of declarative style. But in the case of imperative style, all the statements which are there inside the for loop will be repeated n times, that n iterations will happen. But in the declarative style there is nothing like that. Only once in one shot you will get all the output. So that's why computational, in the case of, like, if you see the computational speed, then declarative is better. But if you see like the memory also, if you see, there is nothing like memory is uh, what there is no memory. We are not allocating any memory for any variable. So in the declarative style it is computationally and memory wise also it's better. But in the case of imperative we need to store the intermediate results, and also like some variables like memory is allocated for this variable my sum, no. So we need to store these all these intermediate results, so that it requires memory, and also the computations also, like the number of iterations also are more in the case of imperative style. So it's our choice, imperative or declarative. But basically declarative is better. That's why all the programming language Java is also like trying to, there is concepts of streams and everything are coming in, because to make our program as declarative as possible. Imperative is time consuming this because of the memory and everything. Okay.
Ma'am, is there any scenario where imperative is better than declarative?
Yeah, currently I can't think of anything particularly now, but we'll let you know if something is there. Actually most of the programming, see, Java is also, there is some new version, like new in the newer versions there are some concepts like streams and other things. So these concepts will make our programming language as declarative as possible. Like python, in the python there are many functions, just this function call will give us the output. But in Java everything is explicit in the previous version. But now this Java programming language is also trying to make the program as declarative as possible by using this newer versions. So we
Okay.
want less code. We want less code. Within the less code, we have to do all the computations. So that's why, yeah, programming language is also preferring this. And we all know, right? The Python is easy to learn, because just some function call will make things to happen. But in Java everything you have to write explicitly. So because it is also one of the reasons newer versions are coming in Java, and it is also enabling our program to make as declarative as possible. Okay.
Excuse me, ma'am. One
Okay.
last question.
Yeah.
Ma'am, if suppose we wanted to compute the factorial of n numbers, so in the imperative approach, we would use a looping technique, whereas
Mhm.
in declarative approach, we'd use recursion, right? So in that case, wouldn't looping be far more efficient than recursion?
See, if yeah, that is the case, no, that is the thing. We have to see the both the cases, like computationally which is faster, and like memory also we have to check based on the things. So sometimes, see, so even if you go for some algorithms, for lesser number of iterations the one algorithm will be better, but for more number of for a higher number, or for more if your number is more, like if you wanted to do some sorting or something, there are different sorting algorithms. But based on the, like, the numbers, based on the size of the input, you may prefer one algorithm over other algorithm. So the algorithm which is faster may not work better on slow on on less data, something like that. So yeah, there is this trade off between this programming styles also. But it's our choice, like we have to decide which one to choose, whether imperative style or declarative style. Okay. There is nothing like best. Okay, it's our choice only based on our requirement and our availability. We have to decide whether imperative or declarative we have to go for. Okay.
Okay, ma'am. But in the context of factorial, which would be better?
In the context of factorial, I will say, like, so it is also depends, no, if your number is, if you have some smaller number. Okay, let us take, if you have some smaller number, then how many iterations you will do for factorial? In the case of imperative style, less number of iterations, right?
Yes, ma'am.
In the case of declarative style, the function call will happen the same number of times. The function call, like if you are doing the factorial of n, then n iterations will happen in the case of imperative style. In the case of declarative style, n times that particular function will be called factorial function, right? Return n into factorial of n minus 1. So factorial function will be called n minus 1 times. It is same in the case of like computation wise. Are you understanding what I'm telling? So if you have factorial of n, if you do iteration, then you will say you will run for loop from 1 to n, and you will say n into like that thing you will compute using the for loop. But in the case of declarative style, you will call the factorial function n minus 1 times, right?
Yes, ma'am.
So the iteration wise it is same, the calling the function is happening every time. So yeah, I cannot like tell whether this imperative or declarative is better, because iteration wise both are same. The for loop will run n times and the function call also will happen n times, n minus 1 times. So it
Is
does
there a
not.
way to compare both of these methods?
Which methods?
Uh,
Imperative and
yeah.
so the only thing, so what you are doing in the imperative or declarative style, it's just coding you are doing. You are writing some program only in both the things. So how do you say which program is better? By seeing the computation speed and also the memory, by checking the memory. So only those things you can do, right?
Yeah, and I want to know if we can check those things.
Yeah,
How
you
can we
can.
check those
Yeah,
things?
you can. Yeah, that is different for each and every program. So so in the imperative style and the declarative style, the same program will occupy different amount of memory and different number of iteration. And it is not like we cannot generally say like imperative or declarative is better, because it varies from program to program. Okay, but majorly declarative is better, because the number of iteration will be lesser in the case of declarative. Just iterations will be less, and also just some function call will give you the output without telling explicitly. So declarative style is, in the major cases it will be better, but there might be some cases where the imperative style will be better over declarative style. Okay.
And can we conclude that if the size of n is smaller, in that case, imperative is better than declarative? And if we go like big value of n, then declarative is better.
Yeah, that we cannot conclude. Okay, any conclusion, specific conclusion we cannot tell specifically, but declarative is majorly in the most cases it is better, because just a function call only, we are just calling some function, we are not telling what to do or how like how to do. We are not telling how to do, we are just telling what to do. I want to filter this, I will get some output. So in the that's why declarative is better, because we are not writing anything explicitly, we are just calling some functions and we are getting output. But in the case of imperative, everything has to be written also, right?
Like
But
we
there
can
might be.
simply record the time before the program and after the execution of program, and then subtracting, we can like calculate the time, how much time imperative take and the declarative, and then we can compare.
Yeah, that is, see, we cannot generalize. So for one program imperative might take less time and the declarative might take more time. For the other programs imperative will take more time and declarative, some conclusion, direct conclusion we cannot draw. It depends on our program, on our code, the way we write our code also. In the case of declarative, imperative as well, so some people will write all the code in the single, in just one line. Yeah, it also depends on our writing style also, in the case of imperative or declarative. So basically in the most cases declarative is considered as better because of less computational time, and also memory, less memory it is occupying. But in the there might be some cases where imperative is preferred over declarative. Okay.
Got it.
Yeah.
So, ma'am, similar to Python, Java also having two styles, imperative and declarative.
Yeah, yes, Java also has two styles. So that concepts you will come to know later. So yeah, that concepts you will come to know in the later weeks, week 8. Okay.
Okay.
Yeah. And previously someone has asked like why, which is why Python is interpreted language and why Java is like compiled language. So in the case of Python, if there are three lines in your code, like print for if the first line is print something, print hello, if you have written without any mistake, then the hello will be printed. And if your second line has some error, then the second line won't be executed. Okay, but in the case of Java, if you have three lines, if your first line is okay, but if your second line has some error, then your code won't generate any output. Okay, so after fixing the line to error, then only the whole code will execute and you will get the output. But in the case of Python, even if your second line has some error, if your first line does not have any error, then the first line will be executed. You will get the output. Okay,
Okay,
that
ma'am.
is the difference between compiler language and compiled language and interpreted language. So the first line will be, in the case of Python, first line will be interpreted, like it will be converted to machine level language or something, you will get the output. But in the case of Java, the thing will be converted into binary code at once. Like the whole thing will be compiled once. If there is some error in any one of the line of your code, you won't get output until and unless you correct that code. But in the case of Python, if even if you have errors in between, all the above lines will be executed and you will get the output. Okay.
So, ma'am, in
Mm.
Java, either the code will fully execute or it will not execute at all.
Yes, you may get output. You will get output only if your code is correct. But in the case of Python, even if your code is not correct, you will get the output till the lines which are correct. Okay, so I told the example, no, if you have three lines, if the first line is correct in Python, you will get output. Like if the first line is print hello, the hello will be printed. But if your second line has some error, then from second line the code won't execute. But in the case of Java, if the first line, even if your first line is correct, but if your second line has some error, then the entire code won't be executed. Like you won't get any output. Okay. Okay. Is it clear?
Yes, ma'am. So, can
Yes,
we
ma'am.
say that in Java, all the test cases will be run if the code is correct, otherwise,
Yes.
none will be run?
Yes. Yeah.
Okay.
Like you won't get any output. That means the code won't run. Only compilation will happen. Running of the code won't, execution of the code won't happen. Okay.
Okay, ma'am, it's clear.
Yeah. Okay. I think Anand sir, you can continue now.
Yeah, okay. Thanks. Yeah. Next one, abstract data type. Okay. So what is abstract data type? So here abstract data type is a structured collection with fixed interface. So here this abstract data type, okay, it is going to expose, okay, what are the operations we are able to perform on the what perform on the data structure, and it won't expose the implementation, it won't expose the implementation. Okay, so here abstract data type, what it is a structured collection with fixed interface. Okay, so here this interface is going to expose what all are the operations we are able to perform on the data structure, and this ADT, abstract data type, won't expose the implementation. So that is abstract data type. So for example, so stack ADT. Okay, so here stack ADT is going to expose the what all are the operations performed on the stack, like push, pop. Okay, so peek. Like this, we are able to perform some operation on the stack data structure. And coming to what queue. Okay, so queue, by using queue data structure, we are able to add elements from both ends. Sorry, from head we are able to add the element. Sorry, from head we are able to remove the element. From rear we are going to add the element. Right. So here it is going to expose. Okay, QADT, Q abstract data type, is going to expose what all are the operations performed on the Q data structure. Okay, for example, okay, some real time example. Okay, so for suppose I visited one restaurant. Okay, I visited one restaurant. Okay, so now here chef is going to prepare the whatever the food we ordered, right? So here how it is prepared, okay, how it is prepared, how it is implemented, okay, we don't know, right? We don't know, but we know what all are the items are available at the restaurant. Am I correct? Hello?
Yes, sir.
Yeah. So now you tell me, what is the interface at the restaurant? What is the interface at the restaurant?
Menu list.
Yes, super. So here menu list, okay, menu list is going to expose, right? Menu list is going to expose just what are the items, okay, what are the items available in that what restaurant. But here, is there any implement? Okay, is there any implementation you found in the menu card? Menu card. Hello. Hello.
Yes, sir, we can hear you.
Yeah.
Yes, sir, we
So
can hear
here
you.
menu card. Yeah, menu card is an what fixed interface. Okay, where we can find what all are the items available in the what restaurant, and we are going to order whatever we want. And internally, chef is going to prepare that and will get it. Okay, so same like here, abstract data type. Okay, it will expose just what all are the operations performed on the data structure, and it won't expose the what internal implementation. Okay, internal implementation of the data structure. Okay, it will separate implementation from interface. So interface contains only what all are the operations performed on the what data structure. Okay, so the internal implementation of the data structure, okay, is hidden. Okay, is hidden from the what interface. Okay, so this hiding the internal implementation, okay, hiding the internal implementation is called abstraction. Okay, abstraction. So here abstract data type provides what abstraction to the what to the data structure. Okay, so it will hide the what internal implementation of the data structure, and it will expose just what are the operations we are able to perform on the data structure. So that is abstract data type. Is it clear?
Sir, could you please explain it once more?
Okay. So abstract data type, okay, so it is a structured collection with fixed interface. Okay, so here abstract data type is going to expose what all are the operations performed on the data structure. Okay, and it won't expose the implementation of the data structure. Okay, simply it is going to separate implementation from interface. So here implementation, okay, is different from data structure to data structure. And here what interface contains, only it will contain, okay, only it will contain what are the operations performed on the data structure. Okay, and how those operations, okay, implemented internally, that won't expose to, okay, outside. Okay, so already I told one example, right? So for suppose if you visited any restaurant, there will be one menu item, so that is called interface. Okay, that is called interface. So that interface contains what all are the what all are the items available in that restaurant. Okay, so you don't know how it is prepared, okay, and who is prepared. Okay, simply you are going to, okay, see that what a menu card interface, and you are going to order, and that will be prepared by chef internally. And how it will be prepared, okay, you don't know, but you will get whatever the food you want. Okay, here
Okay, so
also, okay, yeah.
it's clear.
Sir, except abstract data types is a form of encapsulation.
What?
So
Abstract data type?
are the form in a abstraction.
Yeah, it will provide abstraction, right?
Sorry,
So it will hide
encapsulation. Sorry.
Encapsulation, abstraction, both are different. Okay, encapsulation is different. So you will come to know about encapsulation in later weeks. Okay, yeah, that is different. Actually, that is also one of the what object oriented principle. Okay, so here abstract data type using what abstraction to hide the internal implementation of the data structure. Okay. Next, see, dynamic versus static typing. Now here my question. So here, see, first point, every variable we use has a type. First, what is variable? What is variable? That is my question.
That can store data.
Okay. First,
That
suppose.
That
Okay.
can store a value.
Yeah, yeah. I'm asking.
and it
Yeah, I'm
data.
asking one question. Okay. I don't know who answered for this variable first. May I know who is that?
Me.
Yeah, yeah. Okay. So please tell me. 2 plus 3.
What?
2 plus 3. Addition of 2 and 3.
5.
Okay. So here addition of 2 and 3 is 5, right?
Yeah.
So here first you should remember 2 and you should remember 3 in your brain. Am I correct?
Hmm.
Inputs you should remember. After that, okay, after that you should apply addition operation on that, and later you should store the result in your brain. Am I correct?
Yeah.
Yeah, same like here also. So if you want to perform any operation, okay, in computer, okay, first, okay, you should store your inputs, right? And you are going to perform operation on that what input, and you are going to store the result into the memory, right? So here your data is going to store in the memory, but is it possible to see your data in the memory directly? No, right?
No, no.
No. So here variable is symbolic representation of your memory. Symbolic representation of your memory. Your see here x is equal to 10, right? X is equal to 10 means here you are storing x into 10. Sorry, 10 into x, right? Here really you are not storing this 10 into x. So indirectly it is pointed to the physical memory. Am I correct?
Hmm.
Right. So here variable is what? Symbolic representation of the memory location. Okay. Symbolic representation of the memory location. So here we should ensure, okay, we should ensure. So if you take one variable, we should ensure which type of data it is stored. Am I correct?
Yeah.
Yeah.
Int.
So now how type of variable is determined? Okay. How is the type of a variable is determined? Okay. So if you consider Python programming language, okay, so here variable type is determined at the time of execution. Okay, at the time of execution, for suppose x is equal to 10 means, x is equal to 10 means at the time of execution, okay, at the time of execution, this x will become type of int. Okay, x will become type of int. And here see x is equal to 7.5. X is equal to 7.5. Now this x become what? Float data type at the time of execution. Okay, at the time of execution. So in Python, okay, so we are going to decide type of variable at runtime. Okay, at the time of execution. But whereas coming to Java, okay, so if you try to, okay, assign value to a variable like this, okay, so we will get compile time error. Why? Because okay, in Java we have data types. Okay, so here we should, okay, we should mention the type of, okay, data type of the variable. Okay, data type of the variable. In Python we no need to mention what like this. See here int x, right? Float a. So here we are mentioning, in Java we are mentioning int x float a. Now this x is a variable of type int, but here, okay, so here variable type is decided at the time of execution based on the value which is okay, assigned to it. Okay, which is assigned to it. Based on the value which is assigned to it, okay, we are able to tell which type of variable it is. Okay, so this happens x is equal to 10, right? So this will happens at the time of execution. So here Python uses dynamic typing. Okay, so names derive type from what current value. Okay, whatever the value you are assigning to that variable, based on that the type is derived. Okay, for suppose if I change x is equal to, in single quotes I'm writing some Java. Now you tell me what type of variable it is. See,
String.
String.
yeah, right, x is equal to, okay, some Java. So now it is what string type. Okay, but in Java, okay, in Java we use static typing only. Okay, so int x is equal to 10. Okay, but suppose if you want to assign like this, okay, x is equal to 10.5. Okay, at the time of compilation only your compiler will tell, okay, your compiler will tell, okay, so this is, okay, incorrect assignment, incompatible types. Simply it will tell what are incompatible types. So by using static typing, okay, we can catch the bugs early. Okay, we can catch the bugs early in static typing, but in dynamic typing we cannot catch the bugs. Okay, for suppose, one second, let me finish first. For suppose x is equal to 10.
Sir, could you please run this all code and show us the error?
What? Yeah, one second, I will explain. See, x is equal to 10, okay, and y is equal to 20. Okay, now, sorry, now I want to perform addition operation. Now you tell me, for suppose I have written like this, print x plus y. Now you tell me what is the output.
1020.
So this is in Java or Python?
This is Python only. Here I am
Okay,
not
Python
using
is
any.
That will result in an error in Java.
Now you tell me what is the output.
concatenation 102.
Yeah, so 1020 will be printed. But is this correct output? Is this correct output?
No.
No.
That we want? No, right? Okay, for suppose in Java. Okay, so int x and this is int y, right? Now here in Java will represent string like this. Int x is equal to 10, y is equal to 20. Okay, now in Java we use special syntax to print the output, system.out.print or println. Now you tell me what is the output.
It's an error. Invalid value for y.
So here we are going to catch the bugs early. See, here int y is y, right? Int y means this is what y is a variable of type int. Okay, of type int. Now you are trying to assign which value here? 20, right? 20. So now at the time of compilation, your compiler, okay, your compiler is going to, okay, so identify this and it will generate an error. Okay, so like this we can catch bugs early in static typing. Okay, so Java
Sir,
uses
it should be like print ln instead of print.
You can use print or println, both.
Okay.
Okay,
Print
so
prints
println
without
will
a line.
print line by line. Okay, println will print the output line by line. Print will print only in the same line. Okay, simply,
Okay, sir.
so println means, okay, println means plus slash n. Okay, slash n, like this. Okay, it is equal to system.out.println. One second. So here we no need to add. Both are same. Both are same.
Got it, sir.
Okay.
Sir, I didn't get. Please repeat that.
Which one? System.out.println.
Yeah.
Yeah. See, system.out.print of. Okay. So if you write like this, it will print, okay, your output, and it won't go to the new line. So if you want to go to the new line, you should add slash n like this explicitly. Okay. So for suppose, yeah, I'll tell you clearly. Yeah. So here I want to print I want to print addition and subtraction of two numbers. So these two are valid, right now? Yeah, now, yeah, x plus y, addition, and I want to print subtraction of these two numbers. Okay. Uh, Now, how output will be printed? For here, it will print what?
30.
Tell me. 30,
30.
right? Yeah, 30. Next, what is the output of x minus y?
Minus 10.
Minus 10. So it will print like this. So it want to take new line for the next instruction.
Okay, in printing the answer.
Println. If you use println, then it will print what? X plus y. Okay, 30. After that, it will take new line. See, ln is there, no? So it will take new line. Now, next instruction will print on the next line.
Got it, sir.
Yeah. So that is the difference.
So this language is Java.
Yes.
Yeah, this is Java only.
Yeah, so we are using ln just to get to the next line.
Yes, yes.
Okay. And what is this symbol after 20? Int y equals to 20. You use dash 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 and then.
One second. Which one you are asking about? This one, no symbol, no symbol.
The second line, sir.
Yeah.
Yeah. Okay.
Every statement should end with the semicolon. Okay. So Java follows. It is what a strictly type language. So you should follow the syntax rules of Java programming language carefully. Okay. This is not like what a Python. Okay, every statement should end with the semicolon.
Got it, sir.
Hello, sir.
Yeah, Sneha.
Sir, which compiler we will use, sir?
Which compiler means Java compiler only?
No, like which tool we will use, like VS Code or something, which we will use.
Okay, to write the program, right?
So, yes.
So we can use Eclipse.
Okay, sir.
And you can use Replit also.
Okay, yes.
Yeah.
We are familiar with Replit actually.
Okay, if you are familiar with Replit, you can practice on the Replit also. That is also fine.
So can we use VS Code also?
Yeah.
I'm not aware of VS Code. If anybody aware of VS Code, please answer for this.
Yeah,
you can use VS Code, but you will have to compile manually, I think.
Okay.
Using Java command.
.java extension we have to use in VS Code.
Yes.
No, you have to compile using the command line.
No, .java extension is also used. Can use.
Yeah, but you will save the file with Java, but you will have to compile using the command line.
No, I just normally run it actually. Okay.
JetBrains IDE IntelliJ is also a good idea.
Yeah, IntelliJ idea is I think the best.
Yeah, it's so good. Like for Java, IntelliJ, and for like Python, PyCharm is the best thing.
Yeah, it's better to practice on Replit. Why? Because mostly live coding sessions will be conducted on Replit only.
Okay.
Yeah, so it's better to practice on Replit.
Okay.
It's not only for everyone. Okay. So this is clear, right? Dynamic versus static typing.
Yes, sir.
Okay. So I'm moving to next one. So memory stack. Yeah. See here. So this is very important. Activation record. Okay. Yeah. See, each function needs storage for local variables. So here, whenever you call a function, okay, so your function may have local variables, right? So for these local variables, you need storage. Okay. So whenever you call, whenever one function call happens, one activation record is inserted into the memory stack. Okay. So in Java, we have Java virtual machine. Okay. So it will provide a runtime environment to the Java program. So in that JVM, we have stack memory. Okay. We have stack and heap also. Okay. So in this stack, so whenever you call a function, Okay, whenever you call a function, so one activation record is going to inserted. Okay, one activation record is going to inserted for every function call. Okay, every function call. For suppose you created a function and you called that function 5 times. So 5 times, okay, the what five activation records are inserted into the memory stack. Okay, yeah, I'll tell you this one with an example. See here, I'm going to find out factorial of, yeah, 1 second. Sure. Yeah, see, this is visible, right? Factorial of n for everyone.
Sir, it's not shared.
I'm presenting, right? My screen visible now?
Your
Let's go.
screen is
Let's go.
visible, but
Yeah, now?
yeah, now it's visible.
Okay. Okay, see here, this is a function. Okay, I have written to find out factorial of a, okay, factorial of a given number. Okay, now see here, I'm going to check if n is equal to 1, return 1. Otherwise, I'm returning n into factorial of n minus 1. Okay, n minus 1. Now here I'm giving 5. Okay, I'm giving 5. Now you tell me how it is executed. So here you are passing n is equal to 5. Now this n is initialized with 5. Now 5 is equal to 1. Is it correct? Is it true? Hello?
No, sir.
No. So by ignoring this if statement, it is going to, okay, it is going to return n into factorial of n minus 1. Now you tell me here 5 into factorial of n minus 1. Now you tell me. You tell me what happened here. One more function call is happened. What is that function call?
Recursion.
Like n equal to 4.
Yeah. So here n into factorial of, okay, 5 minus 1. 5 minus 1 means factorial of 4. Okay. So here I am calling factorial of 5. But internally, factorial of 5 is calling what? Factorial of 4. Am I correct?
Yes, sir.
Yes, sir.
Yeah, now coming to factorial of 4. Okay. Yeah, factorial of 4. Now 4 is not is equal to 1. So simply it is coming to here, and 4 into factorial of what? 4 minus 1. Okay. 4 minus 1. 4 minus 1 means 3. Factorial of 3 is called by the factorial of 4. Am I correct?
Yes, sir.
Yeah, now 3. 3 is going to call factorial of 2. And factorial of 2 is going to call factorial of 1. And whenever you come to factorial of 1, here the recursive call will be ended. Why? Because whenever n value is 1, it is going to return 1. And now you tell me this factorial of 1 value, return value is, okay, return value is, okay, sent to which one?
To the
Where to store this factorial of 1 result. Where to store, my question is where to store this factorial of 1 value. Who is calling this factorial of 1?
Factorial n.
The previous call.
Yeah, what is that previous call?
That factorial n is
Factorial of 2.
Yes. So here, okay, this factorial of 1, okay,
Okay.
result,
Got it.
okay, result store in the what? Factorial of 2. Now factorial of 2 value store to the what?
Factorial of
Store to
3.
the factorial of 3. And factorial of 3 value store to the 4.
Factorial of 4.
Yeah, factorial of 4 value is stored to the what? Factorial of 5. Am I correct?
Yeah.
Yeah.
Yes, sir.
So here, okay, so here whenever you call any function, okay, whenever you call any function, yeah, second, I'm going to take paint for better explanation. See. First, okay, you are calling factorial of 5. Am I correct? Yeah. So this is factorial of 5. So here, So now this is activation record. Okay. So inserted into the what memory stack. Okay. So here storage for fact of 5. Okay. So fact of 5. And here what is the intermediate variable? What is the intermediate variable here? See if you see here. Yeah, see storage of factorial 5. 5 I'm taking. Okay, you no need to worry. And here value. Sorry. Here intermediate value is 5. Sorry. Yeah, 5 only. So n value. So this is n local variable and 5. Yeah. Now if n is 1, it is going to return what? It is going to return 1, right? But here n is not equal to 5. Okay, not equal to 5. Now what it will return? So it will return n into fact of n minus 1. Okay,
4.
n minus 1 means here 5 into fact of 4. Am I correct?
Yeah.
Okay, and now it is going to call factor 4. Now what happened? One more activation record is inserted. Okay, one more activation record is inserted, and every activation record contains two more things. I'll tell you what are those. Now here storage for what? Storage for fact of 4. Okay, storage for fact of 4. Now here n value is what? 4, and here n is not equal to what? 1, right? So here also 4 into, okay, 4 into fact of, okay, fact of 3. Okay, fact of 3, and every activation record contains, see in the picture, control link and a return value link. See, control link and a return value link. So control link is pointed to the previous activation record. Okay, previous activation record, and the return value link. Okay, so return value link tells where to store the result. Okay, where to store the result. See here I have control link. Okay, control link. Sorry, second. Control link and return value link. I'll tell you clearly. Return value link. Now you tell me this return value link. Okay, return value link is point to here. See, point to here. Am I correct?
Sir, I didn't understand after this line 4 into fact 3. This is this I get, but control link and return value, what is this?
Yeah. So here return value link tells where to store our result. Where to store the result. And here control link points to the previous activation record. Okay. So I'll tell you clearly. You no need to worry. Yeah. See. Now, who is calling this factorial of 4? Who is calling this factorial of 4?
Factorial of 5.
Factorial of 5. So this control link will points to the previous activation record. So what is the previous activation record before factorial of 4?
Factorial of 4.
Factorial of 5. So it is going to point to the previous activation record. Control link is going to point to the previous activation record. Now return value link, it tells where to store the result. Okay, where to store the result. See here where we are calling this factorial of 4 here, right? So this whatever the result generated, okay, whatever the result generated by this factorial of 4, that is going to replace here. So return value link tells where to store the result. So here we should store the result. Am I correct?
Yes, sir.
Yeah. So now for factorial of 3. Now you tell me for factorial of 3. Sorry. Factorial of 3. Yeah, tell me. So here we have control link and return value link. One second. Control link. Control link. Return value link.
Sir, so the storage fact 5 will have the value 4 into fact of 3 because of the return value link?
What? Can you please tell me?
Sir,
Once
the
again.
first stack, the storage fact 5, will it be returned 4 into fact 3 because of the return value link?
No. See here, this is heading actually. So storage means this is total storage. Okay. Hello.
Sir, are they not separate stacks? Or is it just one stack?
Only one stack only. All are inserted into the same stack. Okay. First it will be inserted. Next it will be inserted. Okay. And next fact of 4 will be inserted. Fact of 3 will be inserted. Okay. So fact of 3 inserted. So now here n value is 3. And it is going to call what? 3 into fact of 2. Okay. Here also we have control link and return value. Reduce size. Yeah. Now you tell me here this control link is pointed to factorial of 4 or factorial of 5. Here factorial 3.
Factorial of 4.
Yeah.
Factorial
So it is pointing to the what? Factorial of 4 like this. And return value link points to, okay,
4
it
into
will tell
factorial
where
of
to
3.
store the, yeah, so here it is going to store the result. So like this, okay, like this activation records are inserted into the stack for every function call. Okay. Now see how activation records are inserted into the stack. I'll tell you. Okay, I'll tell you. I
Excuse me,
got your
sir.
question. Yeah.
So to summarize here, can we say that control link will point towards the previous call, the previous function,
Yeah.
the storage fact 4, and the return value link will point towards the return value of that previous function.
Yes.
Okay.
Yeah. Now see how these activation records are inserted into the stack. I'll tell you. Okay. So this is fine, right? This is fine, right? And factorial of 2 is pointing to the factorial of 2. Control link will points to the factorial of 3. Am I correct? And factorial of 1 is control link will points to the factorial of 2. Am I correct?
Yes.
Yeah, this is fine, right? Yeah, now I'll tell you how these activation records are inserted in the stack. See. Yeah. Now, activation record for, okay, first factorial of 5 will be inserted. Okay. Yeah. Now, this is activation record of factorial of 5. Okay. Next, factorial of 4. Okay. So, who is calling this factorial of 4? Who is calling this factorial of 4?
Factorial of 5.
Factorial of 5.
Yeah, factorial of 5. 3, 2, 1. Now, factorial of 3. factorial of 2 factorial of 1. Okay. Now like this, okay, like this, what activation records are inserted for what 5 function calls. Okay. Now here this factorial of 4 control link will point to the factorial of 5. Okay. At factorial of 3, okay, factorial of 3 control link will point to the factorial of 4, and factorial of 2 control link will point to the factorial of 3, and factorial of 1 control link will point to the factorial of 2. Okay, so like this, and its return value, okay, will be stored to the factorial of 2. Okay, where we are calling like n into factorial of n minus 1. Okay, yeah. Now here see, whenever function execution is over, okay, immediately whatever the activation record you created for any function call, okay, so sorry, we are not creating, whatever the activation record is inserted into the stack, that is immediately popped out from the stack whenever its execution is over. Okay, yeah, see here, you see this one here, factorial of 5, totally 5 function calls happened here, right? So among these 5 function calls, okay, among these 5 function calls, which activation record is popped out from this stack first? That is my question.
Factorial 1.
Why?
Because it is going to get executed first, so it would be out, then the factorial 2, like that.
Okay. Okay.
The one which is finishing completely, then it will go
Yes.
out.
Yes, yes, so super. See here, factorial of 5, okay, will be executed, okay, depends on the value returned by the factorial of 4. Am I correct? Am I correct? So
Yes,
here
sir.
factorial of 5 is depends on the factorial of 4, and factorial of 4 depends on the factorial of 3. Okay, factorial 2 is depends on the factorial of 1. So here whenever factorial of 1 executes, okay, so it will return some value. That value is, okay, returned to the factorial of 2. And whenever its execution is finished, immediately it is popped out from the activation stack. It is popped out from the memory stack. And factorial of 2 got required value from factorial 1, right? Now factorial of 2 also it is going to execute, and it will return value to the, okay, it will return value to the factorial of 3 using its return value link, and it is going to pop out after factorial of 2, factorial of 3, factorial of 4, at last factorial of 5. Like this, okay, activation records are inserted and popped out. Is this clear?
Yes, sir.
Yes.
Okay. So next, scope of a variable. So I think you are aware of scope of a variable. So what is scope of a variable? Scope of a variable. Yeah, I'll come to this. Then you can easily understand. Now, take this example at imperative side. Now you tell me, what is the scope of my sum?
Square sum function. Square sum function.
These kinds of functions.
Square even.
Hello. What is the
Inside the
scope of
function,
my
Square.
sum?
Some
Within the
square even.
some square even. So you can use anywhere, right? You can use anywhere in the some square even function, right? So that's why here you are returning my sum. Okay. So for suppose I want to write this x variable outside of this for loop. Anna, you tell me, is it valid?
No.
Why? Why it is not
because,
valid?
because like we can't
Because
access
it's
that
outside
X
the
variable.
scope.
Okay, so this is not local variable for this for loop, right? For loop. So here its scope, okay, its scope is within the loop, okay, and here my sum you declared here, and you are using within the for loop, right? Within the for loop. Why? Because okay, this my sum scope is within the sum square even function. Okay, so here scope means region of the variable, okay, region of the program where variable is available for use. Okay, what is scope? Scope is nothing but, okay, so region of the program where variable is available for use. So here, okay, my sum is can be accessed within this sum square even function. But whereas coming to x, Anna, you tell me, coming to x.
The for loop.
Okay, you should access within the for loop only. Okay, next, what is the lifetime? Lifetime of a variable. Lifetime of the variable.
While the loop lasts.
The time for which we are occupying the memory.
Okay, see here. One second.
The duration for which memory is allocated to that variable.
Yes, yes. So, yeah, now factor storage of fact of 5, right? And up to fact of 3. See, here, whenever fact of 3, okay, whenever fact of 3 execution is finished. So, here n is variable. For this variable memory allocated, okay, and value is initialized with 3. So, whenever its execution is finished, what happened? This activation record is popped out from the memory stack. Am I correct? Hello.
Yes, sir.
Yes, sir.
Yeah. Now what happened? So this memory is deallocated for this variable. Okay, deallocated for this variable. So here, okay, lifetime of a variable is nothing but how much amount of time it is alive in the memory, right? Hello.
Yes, sir. Yes, sir.
Yeah. Hello.
Yes, sir. You are audible, sir.
Yeah. So here, how much amount of time it is, okay, this variable is available for use. Okay, so whenever its execution is finished, okay, whenever its execution is finished, automatically whatever the memory you allocated for this variable, that is deallocated. Why? Because this activation record is going to pop out from the memory stack. Okay, so that is lifetime. Okay, now my question. Okay, please listen this question carefully. Now for x in range of n plus 1. Okay, for suppose here value of n is 6. Now here for every iteration, okay, for every iteration x value will be changed. What are the possible values of x? What are the possible values of x?
0
to 5.
0 to 5.
Okay. So for every iteration, x value will be changed, right? Hello. X value will be changed. Am I correct?
Yes, sir.
Okay. X value will be changed. So here for every iteration, okay, for every iteration, x value is, okay, x value is inserted into the memory, and whenever that iteration is finished, okay, so that for this x memory will be deallocated. Okay, so freshly, okay, for every iteration the memory is, okay, freshly allocated for this x. Now coming to my sum. What about my sum? What about my sum? So until, okay, this program execution is finished, okay, program execution is finished, this my sum is alive in the what activation record. Am I correct?
Yes, sir.
Yeah, so that is, okay, lifetime of a variable. So scope and a lifetime also completed. Okay, so now I want to move to some object oriented programming. Okay, so first, what is class? Okay, so what is class? So in Python, okay, so those who are completed Python, so they have some knowledge on class. What is class?
It's like a blueprint.
Yeah. Okay, blueprint. Very good. Yeah. So yeah,
Blueprint
see
for the concrete
here.
objects.
Yeah. Okay. So here, object oriented programming, right? So here in Java, so you can take any object and you can write a program on that. For suppose, consider okay your favorite mobile. Okay, so favorite. So nowadays without okay mobile, so we cannot live, right? So that is very essential for everyone. So now I want to write a program. Okay, now I want to write a program for mobile. So mobile is an object. Now I want to describe the mobile. Okay, now I want to describe the mobile. Mobile is an object. So this object we can describe by using a class. Okay, so here what is class? Class is a template and it is going to describe properties and behavior of any object. Okay, behavior of any object. See here class describes some properties and methods. Okay, so properties and methods of what? Object. Okay, and now you tell me, if you consider a mobile, what are the properties? What are the properties you have for a mobile? So mobile have what? Brand, right?
RAM.
Brand and model. Okay, RAM.
Dimensions.
Yeah. Ah, yeah. You can take dimensions also. RAM, right? Internal memory, right? RAM and internal memory. Okay, and you can also some mobiles offer external memory also. So like this, okay, like this, it has some properties. And coming to the behavior, what is the behavior of the what is the behavior of the mobile? Now you tell me, what is the behavior of the mobile? You can call. Okay, you can use for calling, you can use for messaging, and you can use for browsing. So there is lot of behavior of the mobile. Okay, so we can write what various functions of the mobile. So already I told, no, we can use for calling, we can use for messaging, you can use for browsing, and you can also have various applications. Okay, to various applications you can use in the mobile, right? So here class is a template. It describes what? Properties and behavior of an object. Okay, properties and behavior of an object. Okay, so in a class we can create any number of objects for a class. Okay, you can create any number of objects based on your requirement. For suppose I'm writing small example. Okay, don't think too much. See, class mobile. Okay, mobile. I'm taking only 3 variables as of now. Okay, string model, it's string model, and int and uh, you can take it string. Okay, string RAM and ROM means internal memory. RAM ROM. Yeah. Now here mobile. Okay, with 3 properties. Okay, 3 properties. Now some behavior I'm taking. So public, okay, void call. Okay, you can call. You can also message, right? We'll come to know. So what is this public? What is this void later? Okay, so this is behavior. Okay.
So this string is the data type.
Yeah. No. Not data type. In Java, string is a class. We'll discuss in week 2. Okay.
Okay.
It's a user-defined data type.
No, this is predefined only. This is predefined class. The string is a predefined class. We'll discuss about string in week 2. Okay. Yeah. And now see public void call and public void message. Right. Now here mobile describes, this is class, right? What it describes? It describes properties of an object. So here every mobile has what? Model, RAM, row, and what are the operations? Call and message. Okay, call and message. So as of now, I written only few behavior and few what we call properties of a mobile. Now you can create any number of objects for this class. Okay, so let me write main method. I'm writing in short. Okay, yeah, every Java program starts with main method. Okay, yeah, main. Yeah, now so mobile obj is equal to new mobile of. Okay, yeah, so here this is the way of creating an object in Java. Okay, so copy and paste. Now obj2. Okay, here these are called instance variables of the class. Okay, instance variables of the class. So whenever you create an object, okay, whenever you create an object, so this object is okay pointing to these instance variables, means this obj1 has its own model ram row, and mobile obj2 has its own model ram row. Okay, here obj1 is what pointing to its own instance variables, and obj2 also pointing to it with different instance variables, same instance variables, but memory is allocated separately for obj1 and obj2. Okay,
Sir,
obj2. So now, yeah,
the main will be outside the class, right?
no, inside of the class only. If you want to write, you can write inside of the class, or you can write other class like public class test. Okay, so public class test, and here you can write the main method, and you can create objects in this class like this. You can shift main method into another class like this.
Okay, okay.
So public static void main, and here we have
String arguments.
yeah. So like this also you can. Okay, so now here obj1 has its own instance variables and obj2 has its own instance variables. Okay, you can set those values like this. See, obj1 dot okay model is equal to okay some model you can give, and obj1 dot ram you can give some value, and obj1 dot row, same for the obj2 also. So like this, you can create any number of objects for a class. Is this clear?
Is the model public by default?
Model? Okay. So you are asking about those. Okay. So here, by default, it is not public. We should mention it as public explicitly. So by default, we have access specifier, that is default. So here we no need to mention like this is default. So those access specifiers will be introduced later. In later weeks, those access specifiers will be discussed. Yeah, next question.
Sir, what about main and new, sir? New mobile. What is that new and main?
Okay. New and main. Okay, so main is the starting execution block of every Java program. Okay, main is the starting execution block of every Java program. Actually, this main method and object creation all will be discussed in the week 2. Okay, you no need to worry. Okay, you no need to worry. Just theoretically, I'm explaining. Okay, so here new.
Yeah.
Yeah, new is an operator which will allocate memory to the what? Memory to the object, obj1 object. So new mobile means it is going to create an object in the heap memory.
Create a new instance of mobile.
Right? It will create new instance of mobile. Okay. Hello. In week 2, you will come to know in detail about all these things. What is main method? Okay, there we will discuss what is public, what is static, what is void, what is main, what is string out. Everything we'll discuss in week 2. And this object creation. Okay.
Okay, sir.
Yeah. So this is clear, right? So what is class? Class is a template. So it will describe what properties and behavior. Okay, so properties and methods. Okay, so properties and methods of a object, and we can create any number of objects for a class. Okay, based on your requirement, you can create any number of objects for a class. Okay, every object has its own state and behavior. Okay, every object has its own state and behavior. Okay, so here already I told, right? So this obj1 has its own model ram rom, and this obj2 also has its own model ram and rom. Yeah. Now what is object? So object is nothing but concrete instance of a template. Okay, so class, what it describes only properties and methods. Okay, so now here object is nothing but it is concrete instance of a template. Template means class. Okay, concrete instance of a class. So here each object maintains separate copy of local data. Okay, so separate copy of local data means every object, okay, has its own model ram and rom. And mobile 2, see here mobile object 2, this object is also has its own model ram and rom. Okay, and see invoke methods on objects. For suppose here obj1 is there, right? So obj1 dot call and obj2 dot message. Like this we can call the functions also. Okay, like this we can call the functions also if required. Yeah. Now, distinguishing features of object-oriented programming. Yeah. If anybody have any doubt here, please.
Sir, re-explain that object, sir. Object.
Object is nothing but, okay, so concrete instance of a template. Template means class only. Okay, so by using this object, okay, so we can call functions in a class, functions in a class, and every object is associated with its own what instance variables. Okay, instance variables. For suppose, see in this example, so whenever you create an object, okay, let me take one new.
Class and object both are same, sir?
No, different. See, class, what it will describe, what are the instance variables, and it will describe what are the operations we are able to perform on the object. That's it. It will describe, okay, state and behavior of an object. That's it. It won't do anything. And now object is concrete instance. Now we are implementing this mobile. Okay, so whenever you create an object, okay, obj1 like this, what happened? One memory is created for obj1, and now see here ram, rom, and model, right? Now what happened here in memory? Okay, so three things for these three variables, memory will be created for ram, rom, and model. Okay, now you can initialize this ram, rom, and model with respect to this obj1. Okay, with respect to this obj1, and same for obj2. See, whenever you create one more object, okay, what happened again? What memory is allocated for obj2 like this. Now you tell me for this object also. Okay, for this object also separate instance variables are there. Now you can change this. You can initialize this ram, row, model with respect to this obj2. Okay, so here every object. Okay. Hello. So every object is associated with its local copy. Okay, it's local copy. Local copy means every object is associated with its instance variables. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Sir, will you be discussing heap memory?
Okay. See, yeah. So runtime memory is allocated in heap only. So like this. So in Java Virtual Machine, okay, in Java Virtual Machine, we have stack area and heap area. Okay, heap area. In stack, so already I told, right, in stack we are going to allocate memory for instance, sorry, what we call local variables of a function. Okay, so we are going to insert one activation record. Okay, already we have seen scenario, right? So now here dynamically, okay, dynamically allocated memory is allocated in the heap. Okay, so here obj1 and obj2, so these obj1 and obj2, these two objects are created at the time of execution. At the time of execution means, so here you are going to compile this program and you are going to run this program. So here we have two phases, compilation phase and the execution phase. Okay, at the time of compilation, this object, okay, this object can't be created. Why? Because this object is created by the Java virtual machine at the time of execution. So here in heap memory, okay, in heap memory, what this heap contains is dynamically allocated storage. Okay, heap contains the dynamically allocated storage. Okay, so if you want to allocate memory to, okay, any object at runtime, okay, that will be allocated in heap area only. Okay, heap area only. For suppose let's say linked list. Okay, so in linked list internally, what we contain in linked list, if you consider linked list, what will be there inside of the linked list?
Link
So
to
the data
next
and the next
node and link to previous node and the data.
Yeah, so here internally, okay, it contains node, right? So here, now you tell me, for this node, memory is allocated at compile time or runtime. Here, we can't say how many nodes you want to insert. Okay, we can't say how many nodes you want to remove from the linked list, right? So here for linked list, okay, we are going to allocate the memory at the time of execution. Okay, depends on the, okay, depends on your requirement. Okay, you are going to allocate memory, okay, to the linked list at the time of execution. Okay, why? Because based on the user choice, you can add any number of nodes to the linked list and you can remove, okay, a node from the linked list also. Am I correct?
Yes, sir.
Yeah. So this is a best example for dynamically allocated memory. So dynamically allocated memory always, okay, allocated in the what? Allocated in the heap memory. Okay, heap memory is different and stack memory is different. Okay, in stack, in Java, in stack memory, we are going to allocate, okay, memory what? Memory for local variables. Okay, in heap, okay, we are going to allocate memory for objects. Okay, so objects are indirectly pointing to the but instance variables of the class. See, if you see this program, so here you are creating an object, right? obj1. So now memory is allocated for this obj at the time of execution in heap area. Now this obj is pointing to the instance variables of a class. So for these instance variables also, memory allocated at the time of execution. Okay, at the time of execution, this memory will be allocated. For suppose if you write some variable here, x is equal to 10. Now you tell me, for this variable, memory allocated at which time? Memory allocated at which time? Compile time or runtime? Compile time or runtime? Int x is equal to 10 and int y is equal to some 20. Now you tell me, for x and y, memory is allocated at which time?
Compile time.
Yes. Okay, at the time of compilation only memory is allocated. Why? Because for every function call. Okay, so for every function call, what happened? Okay, activation record is inserted into the stack. Okay, inserted into the stack. Okay, and here x is equal to 10, right? So this memory is allocated to the x at the time of compilation only. Okay, now for this string model, RAM and ROM, these are instance variables. Okay, these instance variables declared outside of the function. Okay, outside of the function, and these instance variables are associated with an object. Okay, how many number of objects you created, for every object these instance variables are okay created. Okay, for every object separate instance variables are created. Okay, so dynamically generated okay memory is allocated in heap. Is this clear? Hello.
Sir, so the instance variables will be in the heap.
Yes, in the heap only.
And also the global variables also? Because
Global
local variables will be in the
instance variables are global only, right? See, here these instance variables are global only, right? You can access anywhere, right? You can access anywhere in the class. Am I correct? Within the class, you can access anywhere. So this is global only, right?
Yes, sir. Yes.
This is global only. Yeah. Okay. So is there any particular doubt here?
Sir, in the lecture, professor also discussed garbage collection.
Okay, so now we have automatic garbage collection. Okay, so you say
Your voice is breaking. I guess.
for all or only for you?
It's
Please
breaking,
confirm.
sir.
Yeah, sir, for everyone.
Breaking, right? Okay, let me check once. Yeah, now?
Yeah, sir, it's okay. And about this heap memory, we will get this information in the next weeks, right?
Heap memory? What information you want to get about heap memory? Hello?
Sir,
Am I
actually,
audible?
yeah, in professor, while explaining, he is just given a glimpse about that heap memory and all. But in detail, stack memory and heap memory, you are saying it is different and differently allocated, and how they are linked, how they are called back.
Callback. I'm not getting your question. So already I
How
told, right?
could you explain it again, sir? That I didn't understand.
Okay. See, if you if you consider a class, okay, if you consider a class, so in this class, okay, some variables, okay, for some variables, memory allocated at the time of execution. Okay, so here object is also a reference variable. Okay, reference variable. So for this reference variable object obj1, memory allocated at the time of execution. Okay, at the time of execution. So this dynamically, okay, dynamically allocated memory is allocated in the heap. Okay, but if you consider a function, so if you consider a function, so whenever a function call is happen, okay, so here for this local variables, memory is allocated at the time of compilation only. Memory is allocated at the time of compilation. So whatever the okay memory you are allocating compilation, that memory is allocated on the stack. Did you get my point?
Yeah, sir. Yeah.
Hello.
Thank you, sir.
Yeah.
Sir, what if the function is setting the value for the instance variables? Will that be stored in the stack or heap?
Okay, 1 second. So for suppose, okay, for suppose, here I'm taking one variable int. So int x. Okay. So here I'm changing it to y. Okay. Okay, so x here. Now y is equal to x, and you are printing this y. Okay, you are printing this y. Obj one dot, see here, x is equal to some value, and you are calling obj1 dot obj1 dot x. Is this, you're asking about this?
Yes, sir.
Okay, now here, okay, now here you are passing what? Obj1 dot x, right? Obj1 dot x. Okay, so now here memory is allocated. Okay, so memory is allocated for this x at the time of execution. Am I correct?
Mm-hmm.
Okay, at the time of execution. So here x is equal to 10 is assigned to this what? Obj dot at the time of execution, right? So in this case, what you have to do is first you should initialize it with 0. Okay, initialize it with 0. Later you should assign like this. Why? Because at the time of compilation, so we cannot determine value of this x. Am I correct?
Yes, sir.
Yeah. So now obj1 dot x means this value assigned to this one what at the time of compilation. Sorry, at the time of execution. And at the time of execution, it is going to call this obj1 dot call. This function call is also happen at the time of execution. You can't call this function call at the time of compilation. Okay. So now you should assign like this into y is equal to 0, y is equal to x, and print the y. Okay. Now memory is allocated for y at the time of compilation only. Okay, at the time of compilation only. So later, okay, this x is initialized with 10. That value later changed to what? Whatever the value you are assigning to x. Initially, the value is 0. Okay, and one more thing. See, in C and C++, very important point. Okay, please remember, very important point. Int x, see, int x and print, okay, print x, okay, print x. And now you tell me what is the value of x in C and C++. If anybody aware of,
Some garbage value, I assume.
yes, super. So some garbage value will be printed. But in Java, so if you declare any what local variable, and if you not assigned any value to it, okay, your compiler is going to what? Your compiler is going to generate compilation error. Why? Because in Java, okay, local variable you should initialize. Okay, you should initialize the local variable. Otherwise, your compiler is going to okay generate an error. Okay, there is no garbage value. Okay, we have default value for instance variables, but there is no default value for the what local variable in Java. Okay, local or garbage value. There is no garbage or local value, sorry, default or garbage value for local variables. But for these instance variables, we have what default values. So we'll discuss those default values in week 2. Okay, so please, this is very important point. Okay, you should initialize the instance variable. Sorry, you should initialize the what a local variable in the function. This is clear, right?
Yes, sir.
Yeah. Next, so distinguishing features of object-oriented programming. So already I discussed about abstraction, right? So what is abstraction? So abstraction means okay, hiding the internal details. Okay. So abstract data type is going to okay provide abstraction to the data structure. Okay, it is going to hide the internal implementation, and it is going to expose what all are the operations performed on the data structure. Okay, and
So can you give the example of abstraction using code?
uh, abstraction using code. See, from week 3, you can get a better idea about abstraction. As of now, if I write anything, that will confuse you. That's why.
Okay.
Okay, so actually, yeah, it is expose only what all are the operations performed on the data. Okay, data structure. It won't. For suppose 1 second. Actually, this is question. Yeah. So in Java, we have predefined class, so that is stack. So I'll show you Java C, sorry, not Java C, Java P, Java dot util dot stack. Yeah. Now see, so this is, see, Java P, Java dot util dot stack. Okay. So here stack is a predefined class. Okay, stack is a predefined class. Here you no need to implement the stack. Okay. Now you tell me what are the operations you are able to perform on the stack.
Push pop.
Yeah, see, push, pop, peek, empty, search. So these all are the operations you are able to perform on the stack. But is there any implementation you are able to see here?
No.
No, so this is what abstraction,
Okay, sir.
right? Simply. And we have linked list also. See, linked list. See, these many operations you are able to perform on the what linked list. Okay, just simply create an object of linked list and call these methods. You no need to worry about how these are implemented inside. That is what abstraction. Okay.
Okay,
Yeah. Okay, now next I will discuss inheritance. My voice is clear, right?
Yes, sir.
Okay, okay. Yeah, see, inheritance. So inheritance is very important feature. Okay, so object oriented principle. Okay, so inheritance is nothing but reusing the implementations. Okay, first suppose we have two classes, employee class and a manager class. Okay, so here employee has some what properties, and manager also have some properties. Here every here manager is also an employee, but every employee is not manager. Am I correct? Hello.
Yes, sir. Right.
Yeah, so now employee, whatever the properties employee has, same properties manager also have, right? For suppose if you take employee, so employee has what name, right? Name. Okay, name. Next, date of joining. Okay, salary. Okay, so these are what properties of employee. So now manager. Manager also okay has what name. Next, date of joining and salary. Okay, apart from this, okay, is date of appointing as a manager. Okay, date of appointing as a manager, and he can also set the secretary for his organization. Okay, secretary. So now you tell me here manager. Okay, so manager has same properties. What are the same properties? Name, date of joining, and salary. Okay, so now okay, so we no need to we no need to re-implement these properties of employee, sorry, of manager. See here already this name, date of joining and salary are available in the employee class. Am I correct? So now you no need to redefine these things. Simply we can extend this manager class for this employee class. from the employee. Now, whatever the implementation we have in employee class, that will be inherited to the manager class. And we can use that implementation in manager class. And if you want to add any other additional functionality to the manager, you can add that functionality to the manager also. Okay. So whatever the functionality, okay, is available in employee, all that all that functionality is inherited to the manager. Okay, we no need to redefine. Okay, we no need to redefine the okay functionality available in the employee in manager, so we can simply reuse it. Okay, we are reusing the implementations by using inheritance. Okay, is this clear? Hello. See
Yes, sir.
here, retain basic data of employee objects and add additional fields and functions, date of promotion, okay, and seniority. Okay, like this, if you want to add any extra functionality to the manager, you can add. Okay, there is no restriction that. So if you extend any class from any other class, okay, you should stick with that functionality. Okay, so you can add additional functionality to your manager class. So here employee class is called parent class and manager class is called what child class or sub class. And here employee is called super type and manager is called subtype. Okay, yeah. See here A can be inherited from B. Okay, if and only if A is subtype of B. Now you tell me. Okay, according to this statement. Okay, according to this statement, manager is
Your
subtype
audio
or
is
super
breaking.
type. Okay, so this is visible, right? It is visible, right?
Sir, your voice is breaking.
Yeah, now. Hello.
So now it's okay.
See, here employee manager. Okay, so manager is inherited from employee. Okay, now here
Very
see,
good.
see point. Okay, see this point. Hello. Again, it is breaking up.
Yes, sir. It's still breaking.
That don't know what happened. Okay. Anybody, please confirm whether the voice is audible.
Sir,
Not
voice
audible,
is
sir.
disturbing,
It
sir.
is breaking.
Audible, not audible.
Second.
Hi, hello everyone. Am I audible, right? Hello.
Yes, you're audible.
Yeah, there is some network issue in the like Anand sir. So we'll discuss like remaining topic in next session.
Okay. Thank you.
Okay. Thanks for joining everyone. Yeah, we can find out the session.